Okay, here we are talking about SAT map, and we're going to go over two-way table statistics and probability. Two-way table is basically when you're just comparing two variables, and so we're going to go over that stuff. We are going to get into statistics like mean, median, mode, and also range, standard deviation, margin of error, and also what it means to be symmetric, skew to the left, skew to the right, and we're going to also get into probability and some word problems. So that's the topic: two-way table, statistics, and probability. So let's jump into some of these problems here. So let's take a look at number 4. That deals with like margin of error, it looks like. And that didn't copy and paste again. Let's try this again. Edit, take snapshots, share a little ding. There we go. So 1,600 adults were surveyed. 48% indicated that they get their news from TV. The margin of error is plus or minus 2.5%. Which value is outside the interval that's likely to contain the exact percent of all adults who get the news? Okay, so obviously we want to do 48% times 1,600. And hold on, this question is a little confusing. Which value is outside the interval that's likely to contain the exact percent of all adults? Oh, okay. I think what they want us to do here. Geez, this is a really odd question that's being asked here. Let's see what the answer is, and we'll kind of reverse engineer this one because I do think this is a little bit funky for number 4. Okay, so the answer is A for number 4, which is 45. I do know if you take 48% of 1,600, that would be 50% is 800, 1% 16, so that'd be 32. That would be 768, I believe. And then the margin of error is 2.5%. Oh, I think they're looking at the percentages. Okay, I think I understand now. Oh, that's just so weird. Okay, so I didn't even have to do that. That was a waste of time. 40%, but of course, the margin of error of 2.5%, that means 50.5% might say they get their news from television, or 45.5%. So obviously A would be outside that range. That's a really oddly worded question. So not probably the best one for us to go over. So let's maybe try another one here that's might help. Let's look at number 2. Okay, many people shop online primarily because they get access to product ratings submitted by fellow shoppers. The frequency table shows frequency table above gives the most recent 20 customer ratings for a certain product sold online. What does it mean rating for this product? Okay, the frequency means how many people gave that rating. So 6 people gave it the highest rating. So I'm going to do 6 times 5. And 5 people gave a rating of a 4. 5 people gave a rating of a 3. 3 gave a rating of a 2. And of course, 1 gave a 1. Sometimes you see this often on like a Yelp or Amazon. And this is how it's calculated. They look at how many people gave it the highest rating, how many people gave it the second highest, and they do kind of like what we call a weighted average. And you divide all this by 20 because you're doing 20 customers. So it's 30 plus 20 plus 15 plus 6 plus 1 over 20. That's going to be 65, 72 over 20. Which of course is 3.6. You get A as an apple for that one. Let's keep moving. Take a look at number 9 here. A study of gasoline across a particular state showed that the state's mean gas price was $2.87 per gallon. The median gas price is $3.25 per gallon. Which one most likely accounts for the difference between the mean and the median gas price in the state? So clearly, these are pretty different. Median is the middle number, mean is the actual average. Now, if we go back to our document here, we do see that if it's symmetric, the mean would equal the median, if your distribution works that way. But if the mean is less than the median, which is the case we say it's skewed to the left, meaning that we tend to see more data, a little bit more to the right, and then of course it kind of skews off to the left. And then vice versa, we have the other way around. So the mean is greater than the median, then we say it's skewed to the right. So obviously we're tending to see a little more data pushed to the left, but still skewed to the right. So if the mean is less than the median, which we do have, it's definitely going to be skewed to the right. Sorry, that'd be skewed to the left, as we see there. So we do see a good chunk of our data on the right side, but it kind of tails off towards the left. That's why we say it's skewed to the left. So when I look at this question again, a few areas of the state had substantially lower gas prices than the rest. That would be actually the other way around. A few areas of the state had substantially higher gas prices. And actually, hold on a sec. No, C would make no sense. D makes no sense. Actually, I didn't read this carefully. So a few of the areas has essentially lower gas prices. Yeah, okay, so, sorry, my bad. And that pulled the average down. So we call them outliers. We had a few over here, and the rest of the data points are here. And that's why we see it being skewed to the left, where the mean, right here, the median, was right there. So my apologies. I didn't read the few part. A few areas just have substantially lower gas prices. And so those are the outliers. And so that's what we get A for number 9. And let's look at one more. Let's perhaps take a look at something dealing with mode, like number 13 here. So you got these 5 expressions, x, 2x minus 3, 2x plus 1, 3x minus 4, 3x plus 1. You're told the average is 10. What is the mode of these numbers? So first we got to add them all up. And divide by 5, so that equal to 10. So 50, 50 is going to equal x, 2x, 2x, 3x, 3x, that's 11x. Negative 2, negative 6, negative 5. So 55 equals 11x. Now, if I plug in 5 for x, I get 5, 7, 11, 11, and 16. So clearly 11 shows up twice. That's the mode. If all the numbers were unique, so you have like each number showing up once, then you don't have a mode. And so I guess you would say D perhaps, but or no mode at all. In that case, it's B. Okay, and that concludes this video on